So today we are on 1-3, which is on negative exponents. Our learning target today is to simplify expressions with negative exponents. So here are some rules for simplifying monomials, which we've already talked about. The first one here is the product of powers. If you've got a to the m times a to the n, and notice you've got the same base there of a, and you're multiplying those, you add the powers together, so you get a to the m plus n. So our example there is 5 to the third times 5 to the fourth. You write down the same base, which is 5, and you add the powers. 3 plus 4 there gives you 7. So in your calculator, you can do 5 to the 7th. And then the power of a power rule there, if you've got a to the m and it's to the nth power, you multiply those two powers together, so you get a to the m times n power. So the example there is 3 to the fourth, all to the second power. You can multiply 4 times 2, which gives you 8. So then you can find out what 3 to the 8th on your calculator there is. Negative exponents. In math, we cannot leave our answer with a negative exponent in it, so it's always written in terms of positive exponents. So if you've got 1 over a to the negative n power, it's equal to a to the nth power. So you're going to flip the negative to the inverse side of the equation there, and then it becomes a positive. So, and we'll do some examples here in just shortly. And then I'm going to do the other one down here. If you got a to the negative n, it flips down into the denominator and becomes 1 over a to the n. So notice the power there became positive once you flipped it into the inverse side of the equation. So, and you got 1 over b to the negative 8. You're going to flip the b to the 8th up and make it positive, which becomes b to the 8th. And so then your example down there at the bottom is 2 to the negative 3. You're going to flip 2 to the third to the inverse side of the equation of the fraction there. So you're going to put it down in the denominator. It was up in the numerator. It becomes 2 to the third in the denominator. So it's 1 over 2 to the third. And 2 to the third is 2 times 2 times 2, so it becomes 1 over 8. So let's keep going with our rules here first. Anything to the power of 0 equals, do you know what that equals? It equals 1. So in other words there, if I've got 5 to the 0 there, we know that 5 to the 0 there is going to give us a value there of 1. So let me get that for you. So we end up there with 1. And if I've got x to the 0, it also is a value there of 1. So anything to the power of 0 there is always going to give you a value there of 1. All right, so let's do the quotient of powers rule. If you've got a to the m divided by a to the n, when it was over multiplication, we went ahead and we added the powers together. Now it's over division here, so we're going to subtract the powers. So you get a to the m minus n power. So if you've got 4 to the third divided by 4 to the second down there, you can go ahead and subtract your powers there. 3 minus 2 there is 1. And so we end up there with 4 to the first power, which is 4. So let's simplify some of these. So simplifying those, we end up getting 3 to the negative x there divided by 5 there. The 3 doesn't have a negative power, so we're going to go ahead and leave the 3 up there. And then x to the negative 5, it does have a negative, so we're going to flip it to the inverse side of the equation. So it becomes x to the 5th down here. There's already an x to the 5th down here. It's positive, so we're not going to move it. It's going to stay down there. So now we're just going to follow our rules here. X to the 5th times x to the 5th. We can go ahead and add our powers there together, and we end up getting x to the 10th. And then letter B there, I would do the same thing. I work with my negative powers there first. So I've got 4 doesn't have a negative power. 6 doesn't have a negative power. The x to the 5th doesn't have a negative power, so we're just leaving those all in the same places. But x to the negative 2 does have a negative power, so we're going to move it to the inverse side. It was down the denominator, so we're going to move it up to the numerator. So then we can combine those x's, and we get x to the 7th up here. And then notice that 4, 6 can be reduced down. What goes into 4 that also goes into 6? Well, 2 does. How many times does 2 go into 4? Twice. How many times does 2 go into 6? 3 times. So we get 2 times x to the 7th all over 3. All right, and then letter C there, we want to kind of think through it the same way here. The 32 and the 20, we're not going to do anything with those. They can stay as 32 over 20. But the x to the negative 6 and x to the negative 4, we can flip those to the inverse side. So it becomes x to the 4th up here and x to the 6th down here. So let's reduce down that 32 20ths. What goes into 32 that goes into 20 there? Well, 4 does. How many does 4 go into 32? 8. How many does 4 go into 20 there? 5 times. And then remember, this is over division. This x to the 4th divided by x to the 6th there. You're going to subtract the powers. So 6 minus 4, there's 2. The higher number of power is down in the denominator there, so it's going to become x to the 2nd down here. All right, and then letter D. 8 doesn't have a power. The x has a 4th power. It's positive, so you're not going to move it. The numerator up there has a negative power up there, so I'm going to move it down into the denominator there and make it x to the 6th. So I need a placeholder up here in the numerator, which is a 1. So now I can just simplify. I can't do anything with this 1/8. It's already reduced down as much as possible. But I can combine those x's down there, x to the 4th times x to the 6th there. I can add those powers together, and I get x to the 10th. So 1 over 8 times x to the 10th. All right, so now we just got a whole bunch of these, some practice with these. So let's try some of these out here. So looking at this first one here, I've got x to the negative 5. Looks like I have to move everything. They all have negative powers. So x to the 5th is coming down here. Y to the 6th is coming down here. X to the 2nd. X to the 2nd comes up here in the numerator. And then y to the 7th comes up here. So now what can I do? I can simply subtract my powers here. 5 minus 2 there for the x's there is 3. There's more of them down here in the denominator, so I'm going to make this x to the 3rd down here. Y to the 7th, subtract y to the 7th divided by y to the 6th is y to the 7 minus 6, and 7 minus 6 there is 1. So I simply end up here with just y to the 1st, or just 1. So y over x to the 3rd ends up being my solution. So let's come down here and let's look at letter B here as well. In letter B there, again, I'm going to go ahead and flip these to the inverse side if they're negative powers. X to the negative 6 comes down here and becomes x to the 6. Y to the negative 10 flips down here and becomes y to the 10th. X to the negative 8 flips up, becomes x to the 8th. Notice you're not going to flip up that y to the 2nd because it's a positive exponent. You're going to leave it down there in the denominator. So down here in the denominator, if I combine my y's, 10 plus 2 there is 12, so I get y to the 12th. Up here in my numerator, if I combine my x's, x to the 8th minus divided by x to the 6 becomes x to the 8 minus 6, and 8 minus 6 there's 2. There's more of them up here in the numerator, so it's x to the 2nd up there. Alright, letter C gets to be a little tricky here. We've got 2, and then I've got x to the 3rd is going to flip down here into the denominator. Y the 4th is going to stay up here because it's not a negative power. I've got 2/3 is going to stay down here, but we're going to take everything in there to the 2nd power. So 2/3 the 2nd power. And then we can also take x to the negative 2 to the 2nd power becomes x to the negative 4. Notice you got the power to power, and then I've got y to the 4 to the second power becomes y to the 8th. Alright, so now we can clean that up a little bit. This becomes 2 y to the 4th. We could clean up our y's, but I'm going to wait on that, I think. Let's not simplify those yet. We've got x to the 3rd here. X to the negative 4 can flip up and become x to the 4th. Y the 8th stays down here. And 2/3 the second power becomes 4/9. So 2 to the second power is 4, and 3 to the second power there is 9. So let's go ahead and let's simplify this a little bit more. So we've got a 2 up here. Working with our y's, we got y to the 4th divided by y to the 8th. Subtract your powers and you get y to the 4th. There's more at the bottom, so the y to the 4th is going to come down here. Going to be down there. We got x to the 4th divided by x to the 3rd. Subtract your powers. There's more at the top, so it becomes x to the 1st up here in the numerator, or just x. And then we still got this 4/9 down here. Now, in math, we do not leave 2 fraction bars in our answer there. So notice I've got a division bar there, and I've got a division bar there. We don't leave our answers like that in math. We got to get it down to just one nice fraction. So if you remember, multiplying is what we want to get this as. And to multiply, we can change this division bar. We can change division into a multiplication statement here. So we can go ahead and we can multiply by the reciprocal here. So maybe we'll just deal with our numbers here. I think that might be easiest. Trying to think through what would be easiest here. So I think I'm going to leave my answer here with the x and the y to the 4th, because there's nothing wrong with those. We've got an x and we've got a y to the 4th. It's our numbers here that are kind of messed up here. So I've got 2. Right now it's divided by 4/9. So we can change that into a multiplication statement by flipping the second fraction and change it into multiplication. So then it's up to you. You can cross out as you go, or you could go ahead and just multiply 18/4 and then reduce that down. Or we could reduce it down now. 2 goes in here once, 2 goes in here twice. So I really end up with 9/2. So my 9's going to go here, and my 2's going to go here. So notice we only end up there with one division bar that way. So